Now, there are a couple more things that I want you to learn. Now, essentially, we are trying to make decisions about the population based on our sample. We don't know the reality, which is the population. Ideally, whenever our decision from the sample matches the reality, it is the ideal situation, it's the correct thing to do. So for instance, whenever the null is truly false and our sample guides us to reject the null hypothesis, we're doing the right thing. Whenever the null is true and our sample leads us to conclude that there is nothing to disprove the null, that is also the right decision. Remember, we only say reject the null or fail to reject the null. We never say accept the null. That is just the terminology that is used in statistics. So in these two situations, we're doing the right thing. But whenever there's a mismatch between our decision and the reality, we commit an error. So whenever the null is true, but we end up rejecting it, it's called a type 1 error. And the likelihood of committing a type 1 error is also referred to as alpha. We just saw that alpha is the threshold value of probability, and I'll come back to this in a second. So when the null is true and you reject it, you commit a type 1 error. When the null is false, but you fail to reject it, you commit a type 2 error. Now, there's an easy way to remember this type 1 and type 2 error, and that's to use the story of the boy and the tiger. So the first situation where there is, if you consider the null that there is no tiger, but the boy cries out that there's a tiger and people believe him, no tiger is the null. So the null is true, but people reject the truth. And that is the probability of a type 1 error. In the second instance where there is a tiger, but people don't believe that, the null is false, but people fail to reject the null, they are committing a type 2 error. Now, the probability of committing a type 1 error, given that the null is true, is called alpha. The probability of committing a type 2 error is beta. Ideally, we would want to minimize both alpha and beta, but it turns out that alpha and beta vary in such a way that if one increases, the other falls, and therefore it is really difficult to minimize both at the same time. So here I've given you another example of how to think about alpha and beta, and I'll let you read and understand that on your own. So the goal here is that we want to minimize the likelihood of both of these errors, but it is a challenge to do so. So what we end up doing is we choose a preset level of alpha. We predetermine alpha to be a certain level, and then we focus on minimizing beta. In this course, we'll only learn about what this setting a preset level of alpha means. Remember, we discussed in our example that the threshold for rejecting the null is alpha. So when we set a 5% threshold, the alpha is 5% or 0.05. Now, if you connect that example, the threshold, to this example of committing a type 1 error, alpha is nothing but the probability that I'm allowing myself of committing a type 1 error. Now, in the cheating example, if I set a threshold of 5%, it could very well be the case that there is no cheating happening. But because I see a 1% event showing up, if I see an event which has only a 1% chance of happening, and I see that happening, and because 1% is less than 5%, it leads me to conclude that the null is false. Okay? But in truth, maybe there was no cheating happening, but I've wrongly concluded and rejected the null. So I've essentially committed a type 1 error. But I'm going to allow myself the freedom of committing a type 1 error, and I'm going to give myself a threshold of 5%, a window of 5% to make that mistake. I'll preset that level and say that there cannot be a more than 5% chance that I'll ever commit a type 1 error. And that's the leeway that I make. That's the allowance that I give myself in the beginning of the problem to say that there can only be a 5% chance that I make a mistake like this. And I'm willing to accept and acknowledge that caveat at the beginning. So that is what we mean by alpha being preset at a certain level, and that's the interpretation and intuition behind the threshold level of significance and the type 1 error. And naturally, when you choose different values of alpha, the likelihood that you associate with type 1 error will also change. So I'll stop here, and in the next video, I'll take you through the graphical intuition behind hypothesis testing. And once you get these visual images right, the process of hypothesis testing will flow very smoothly. So I'll see you there.